Okay, this is then the Using Resources knowledge test. Right, what are the four non-renewable resources? Coal, oil, natural gas, and nuclear. Okay, they're reasonably straightforward ones. Non-renewable, meaning that there is a finite amount. At some point they're going to run out. 6 renewable resources. We've got solar, which is obviously from the sun. We've got waves. We've got geothermal. We've got hydroelectric power. We've got tidal. We've got biomass. Okay, I'm just going to chuck in a number 7 as well. We've got wind. Right, so the renewable one, solar, is obviously solar panels, right, which is then renewable, it's continuous, but obviously it doesn't happen in the night. Waves, right, waves is the constant pounding or the movement of the water in the sea, but it's a little bit unpredictable because you don't know when you're going to have big waves, and you might even have 2 bigger waves. Geothermal is where you're using the heat from underneath the ground, right? Now the big advantage of that is the fact that it is always just going to keep on going. The disadvantage is you can only do it in places like New Zealand and Iceland. Hydroelectric power, right, that's where you've got a big lake and you let water out through sluice gates, right, and it turns turbines to make electricity. Fantastic, quick and easy to do. Problem is it costs a fortune to make. Tidal is when you obviously know when the tide comes in and when the tide comes out. You can get different sized tides, but to actually build a tidal barrier, what you have got to do is you almost block the end of an estuary, which then can affect habitats. Biomass is then you're growing plants and then burning them. And then wind is obviously your wind turbines, but it is not particularly very reliable because if it's not windy, you produce no electricity. What are the 3 R's in recycling? Is reduce, reuse, recycle. It's actually really hard writing it down when the first R's there already. So reduce, reuse, recycle. What is an ore? Right, an ore is a rock that contains enough metal to make it financially viable. Right, so basically there's no point in having a rock that's only got a little bit of metal in it, right, and it's going to cost you more money than the metal is worth. So what it's going to be, it's got to be a rock that's got enough metal to make it financially viable so that people then can make money out of it, because that's what the world is all about. There's 3 metals that can be and 3 that can be, right? A bit of a problem there. I might just put a little apostrophe and a T there, and can't be extracted. So what you've got to do here is you've got to look at reactivity series. You look at reactivity series and you look where carbon is. Anything below carbon can be extracted, so zinc, iron, copper. And anything that is above carbon in the reactivity series can't be extracted using carbon, so aluminium, magnesium, calcium, lithium, sodium and potassium. And theoretically they then need to be used electrolysis to get those extracted. What is bioleaching? Bioleaching is the extraction of metals from their ores using living organisms. Right, so what they do is they are living in the environments that have got the ores in them. They will then gradually extract the actual metals themselves and absorb them into the body, and then we then extract them from the living organism. So what is phytomining? Phytomining is where you get plants living on high metal rich areas, and what they do is the plants absorb the metals, and what you then do is you then burn the plants, leaving kind of the metal compounds. Five stages of the life cycle assessment. So what I've now done is I've done it in a list, right? But a good way of doing it is life cycle assessment, right? Do it in your 5 stages, if that's right. 1, 2, 3, 4, 5, right? Because the life cycle means it goes round and around. So what you do is you start with the raw materials. Let's start there, raw materials. Then what you do is you do manufacturing, put an M there, I do a little arrow. Then what you do is you do the distribution, I put a little D there, distribution. Then what you do is you go through the use it phase, and then you go to end of life, Then what it does, it goes back around again, right? And then what you do is you recycle it, okay? And then what you do is you keep on going round and round and round and round, right? And what you've got to do a lot of this time is, in this one, you've got to look at the energy. It's the energy that's included in each one of the individual sections. Potable water. What is potable water? Is water that is drinkable. Okay, not necessarily pure water, right? But it's water that you can drink. It'll have other sort of solid matter in it and minerals and vitamins, not vitamins, minerals in it, right? But it will, you can drink it and it won't make you ill. That's potable water.